Hello, I am Cat Handler, learning, and you are viewing Learning Computer with seeing the natural sights of Indian village. Jai Shri Ram, Jai Hanuman. In the previous lecture, we have talked about the basic principle of operation of magnetic disks like storage organization, storage capacity, and access mechanism. Now, in this lecture, we talk about access time, disk formatting, disk drive, and disk controller in details. Let's talk about the disk access time. It is the time interval between the it is the interval between the time a computer makes a request for transfer of data from a disk system to primary storage and the time this operation completes. To access data stored on a disk, we need to specify the disk address of the desired data in terms of surface or head number, or track or cylinder number, and sector number. A disk stores information always from the beginning of a sector and reads information always from the beginning of a track. Hence, disk access time depends on following three parameters. Latency. Let's talk. The first number is latency. When disk drive positions read and write heads on the specified track, it activates the head on the specified surface. Since the disk is continuously rotating, this head should wait for the specified sector to come under it. This rotational waiting time, that is the time required to spin the specified sector under the head, is called latency. Latency, also known as rotational delay time, is a variable that depends on the distance of a specified sector from initial position of the head on the specified track. It also depends on the rotational speed of the disk, that is anywhere from 300 rpm rotation per minute to 7200 rotation per minute. In this modern time, ultra fast disk can reach this limit to 10,000 to 15,000 rotation per minute or more. Thus, disk system normally specify an average latency which is of the order of 5 to 8 milliseconds. Note that average latency of a disk system is equal to half the time taken by the disk to rotate once. Hence, average latency of a disk system with rotational speed of 3600 rotation per minute will be 0.5 by 3600 minute equals to 8.3 millisecond. Then the next the next point is seek time. When a disk unit receives a read and write command, it first positions the read-write heads on the specified track or cylinder number by moving the access arms assembly in proper direction. The time required to position the read and write heads on the specified tracks is called seek time. Seek time varies depending on the position of access arms assembly. When a read-write command is received, if access arms assembly is on the outermost track and the specified track is the innermost one, seek time will be maximum, and it will be 0 if the access arms assembly already happens to be on the specified track. The average seek time is thus specified for most systems. It is of the order of 10 to 100 milliseconds. To reduce seek time, some disk systems use multiple read and write heads on each accessor. For example, a disk system having two sets of read and write heads for each surface, that is one for inner track and another for outer track, it will reduce average seek time by half. This is because each read and write head needs to cover and move across only half of the total number of tracks. The third point is transfer rate. Let's talk about the transfer rate. It is the rate at which a computer reads and writes data from to a disk into memory. Once the disk drive positions the read and write head on the specified sector, it reads and writes data at a speed determined by the rotational speed of the disk. If rotational speed of a disk is 3600 rotation per minute and the disk has 125 sectors or tracks with 512 bytes per sector, the amount of data transferred in one full revolution of the disk is about 64 kilobytes or 64,000 bytes. Hence, transfer rate of the disk system is 64,000 into 3600 by 60 bytes per second, that is 3.8 megabytes per second approximately. Notice that transfer rate of a disk system depends on density of stored data and rotational speed of the disk. Since data transfer time is negligible due to high transfer rate as compared to seek time and latency, average access time for a disk system is its average seek time plus its average latency. Average access time varies greatly from one type of disk system to another and is anywhere from 60 to 600 milliseconds to 10 milliseconds. Now, since access time for a piece of data stored on a disk depends on its physical location, it is more correct to refer to a disk system as direct access storage device instead of random access storage device. Random access refers to a storage device in which access time of any data is independent of its physical location. For example, primary storage is random access storage. However, we do not observe the distinction strictly and refer to this system as random access storage devices. Now we know, now let's talk about the disk formatting system. Magnetic disk comes in different size. The size of a disk is usually referred to by its diameter. The typical disk size includes 40 inch, 9 inch, 8 inch, 5 and 1/4 inch, 3 and half inch and 3 and 1/4 inch diameter. Clearly, for proper match of dimension, different size disks requires different disk drive. Even for disks of same size, all disk drives are not the same because disk drives of different computers often have their own way of defining tracks, sectors and sector size to match their own way of organizing data. This implies that computer manufacturers should also manufacture the disks used in their computer system. This is a severe limitation because it prevents use of disks manufactured by third-party vendors into one's own computer system. To overcome this problem, the earlier computer system provided low-level disk formatting utility. It enabled a user to prepare or format a new disk before using it with the computer system. For this, the user had to insert the raw, that is unformatted disk, in the disk drive of the computer system and initiate disk formatting command. The read and write head of the disk drive then laid down a magnetic pattern on the disk surface, making it compatible for use with it. Modern disk drives do not require low-level formatting because modern disk controllers present a consistent view of disk geometry to the computer while hiding the internal hardware arrangement. They accept and can work directly with disks that are factory formatted by their manufacturers. In fact, running a generic low-level format on this disk can cause irreparable damage to drive hardware. For this reason, modern computer systems do not provide low-level disk formatting utility. Now, to store files and data on disk, the operating system creates a file system on the disk. It maintains a table with the sector and track location of data on the disk. This table, known as file allocation table, that is called FAT, F-A-T, FAT, file allocation table, and enables the computer to locate data easily. The operating system disk formatting command take care of scanning and marking bad sectors, creating the FAT, and setting aside sufficient disk space for it. After disk formatting, let's discuss about the disk drive of this system. We have to mount a magnetic disk on a disk drive for reading and writing of data from it. A disk drive contains all mechanical, electrical, and electronic components for holding one or more disks and for reading and writing of data from it. It contains a central shaft on which the disks are mounted, an access arm assembly, a set of read and write heads, and motors to rotate the disk and move the access arms assembly. All the disk drives vary greatly in their shape and size. That is, disk drives vary in their shape and size and disk formatting pattern. Now we can classify them broadly into two types. The first one is disk drive with fixed disks. These disk drives come along with a set of permanently fixed disks. The disk read and write heads and the access mechanism of the disk drives are housed permanently in a sealed, contamination-free container. Sealed packaging allows the disk to operate in a dust-free environment. This enables designer to provide increased data density on each square inch of disk surface by reducing the distance between a read-write head and its corresponding disk surface. Hence, as compared to disk drives with interchangeable disks, these disk drives provide larger storage capacity with same size disk and same number of disk surfaces. However, the disks are not removable from their disk drives because of sealed packaging. Thus, the storage capacity of this disk system is limited. Let's now the second type of disk drive is disk drives with interchangeable disks. This disk drive allows loading and use of different disks in the same disk drive at different instances, enabling offline storage of data on disk. They provide virtually unlimited capacity to a disk system because as many disks as required can be used one after another to store very large data sets. From So we see that there are two types of disk drive. The first one is disk drives with fixed disks and the second one is disk drives with interchangeable disks. Now let's talk about the disk controller. A disk controller controls a disk drive connected to it and interprets the commands for operating the disk drive. Since disk is a direct access of storage device, typically a disk controller supports only read and write commands. Now user has to specify disk address, that is surface number, cylinder or track number or sector number, as a parameter to read and write commands. Often a disk controller controls more than one disk drive connected to it. In this case, the user also has to specify disk drive number as a parameter to read and write commands. From this, I end this lecture. Let's tell Bajrang Bali ki jai.